So, maybe I'm exaggerating a little bit. This will at least give you the cocktail conversation of the three things that you will need to know. But seriously, three concepts that are going to come up and actually be central throughout all three quarters, and we will touch on them all this quarter. Stereochemistry, the three-dimensional structure of molecules, the three-dimensional arrangement of atoms in space. This is where organic chemistry gets fun. We're completely different than general chemistry. That's why we actually get to play with these molecular models, because there is very little other than a tangible molecular model that you can rotate and manipulate that can get things into your brain so well. I work with some very big molecules, and sometimes it's not practical for me to make a plastic model. So I use computer-based models. But to get it really into my brain, I'll put on 3D glasses so I can see it in 3D, because nothing replaces that three-dimensional relationship of being able to rotate and manipulate and so forth. And we will use our plastic molecular models to help us learn about this, to learn about the shapes of molecules and so forth. The second big concept of organic chemistry is functional groups. These are collections, small collections of atoms that have specific properties. So, for example, alcohol, which commonly refers to ethyl alcohol, has very similar properties to methanol, methyl alcohol, and isopropanol, isopropyl alcohol, because they all contain the hydroxy functional group. This group of an OH imparts very similar properties to the molecule. This is a powerful concept because it means if you can predict, or if you know the properties of one molecule with a functional group, you can predict properties of other molecules with that functional group, chemical properties and physical properties. Ethanol is much higher boiling than, say, propane, because the alcohol groups hydrogen bond together. It's also much higher boiling than ethane. I took propane because it's the same, roughly the same number of atoms. Methanol also has a higher boiling point. Ethanol mixes with water, methanol mixes with water. We will learn about functional groups throughout the three quarters, like carboxylic acids, ketones, aldehydes, carbonyl functional groups, and so forth. And you will see that one molecule, knowing the behavior of the functional group, can allow you to predict and understand the properties of many, many different molecules. And so that is why this is such an important concept. This is different than general chemistry because we are seeing more in the way of patterns. And this is where organic chemistry really opens up to people, where they say, well, I didn't really like all that calculator stuff and the logs and the various equations and the Nernst equation and so forth of general chemistry. And they get turned on when they see these patterns in organic chemistry. The last big concept is curved arrow notation. Reactivity of organic chemicals is all about flow of electrons. And if you understand where the electrons are and what wants to get electrons, who has the electrons and who wants the electrons, these are properties of functional groups, then you can figure out how different molecules react. And curved arrows are ways that we show the flow of electrons that in turn shows us where bonds form. Because when you share a pair of electrons, you form a covalent bond. When you take away a pair of electrons, you break a covalent bond. And so we are going to use a very simple notation like so to show electrons flowing from something that has electrons to something that wants electrons.